Hey guys, welcome to our note 7.3, volume using the shell method. So this is another method to find volumes of solids of revolution. So sometimes you'll use disks, sometimes you'll use washer, and sometimes you can use shell. And it's up to you to determine which method is the easiest to apply in a problem. So here is a function f of x, right? And if I rotated it about the x-axis, if I try to do the washer method here, both my inner and my outer radius are the same function. That doesn't work. So what we mathematicians realized is what we could do is take one Riemann sum rectangle and rotate it around and get infinitely many Riemann sums of shells of cylinders with dx thickness. So it's a thickness of dx rotated around the y-axis, and then another thickness of dx rotated around the y-axis, and then another rectangle rotated around the y-axis. So that is a width that they go around of a circumference, 2 pi r, multiplied by the height of your Riemann sum and its thickness. So in this instance, 2 pi r, our radius is going to be a constant change in x. So my radius was x, the height of my Riemann sum rectangle was f of x, and the thickness is dx. So volume is the integral from a to b of 2 pi x, f of x, dx. The other option is if I have a similar function of y rotated around the x-axis. So remember, I can't do a washer here because the inner and the outer radius are the same function. So I can take a Riemann sum and rotate it around, and then another Riemann sum and rotate it around, and then another Riemann sum and rotate it around to create cylindrical shells. So 2 pi RH multiplied by the thickness. In this instance, my radius is going to be a constant change in y. It's going to change my y values all the way up. And then the height of my Riemann sum is f of y, and the thickness is dy. So whenever I'm using cylindrical shells, I like to draw a sample shell so I can visualize what's happening. So we're going to try some problems now where using cylindrical shells is the best method for a method of rotation.